Hello everyone, my name is Jerry Ellison Mutiabele and I'll be taking you through a brief overview of the process of apoptosis and the differences between apoptosis and necrosis. First of all, what do we understand by apoptosis? This is a self-induced death of some cells within a tissue of a living animal, or it is a programmed cell death or cell suicide. Apoptosis is simply where the cell induces its own death, or it brings about its own death, and it is characterized by, or this is how apoptosis presents: the appearance of the cells during apoptosis. 1. Cell shrinkage, where the cells become smaller and denser compared to normal cells. Disruption of the cytoskeleton, but the membrane remains intact. We shall come to see about the membrane remaining intact when you're comparing apoptosis and necrosis. The disruption of the cytoskeleton is as a result of its breakdown by protease enzymes called caspases, as we shall see during the mechanisms of apoptosis. Another change is in the organelles, where chromatin of nucleus is electron dense. So the chromatin within the nucleus condenses, leading to formation of dense, irregularly shaped masses with half-moon configuration, and the nuclei also break up into multiple dense membrane-bound masses. Another thing we shall see is the plasma membrane emitting buds, which can also be referred to as cellular blebbing. So during this process, the cell membrane forms irregular protrusions called blebs, which result from the reorganization of cytoskeleton proteins. So, apoptosis can either be physiological or pathological. Physiological apoptosis is seen in organ involution during embryogenesis and also during growth, i.e. the tail in tadpoles. We see this when tadpoles are developing, their tail tends to become, it undergoes involution due to apoptosis, leading to complete disappearance of the tail, which is a normal physiological process. So we also have pathological apoptosis, which is seen where there is irreparable DNA damage to cells caused by viruses or toxins, radiations, and defects in the DNA repair systems. That is pathological apoptosis. So let's move to the mechanism of apoptosis. How does apoptosis occur? It simply occurs in two phases, that is the initiation and the activation phase. So the initiation phase involves activation of caspases, which are protease enzymes involved in apoptosis. And we also have an execution phase in which the action of these caspases leads to cell death. Alright, so the initiation phase follows two pathways. One is the extrinsic stroke extracellular and the intrinsic or intracellular pathway, and that is the initiation phase. So we'll start by looking at the intrinsic pathway. just as it is stated, intrinsic, meaning inside, and in this case inside the cell. So the intrinsic pathway is initiated by signals from within the cell or inside the cell. It is regulated by maintaining a state of balance between two sets of protein in the mitochondria membrane, that is, the anti-apoptotic proteins, i.e. BCL2 and BCLX, together with the pro-apoptotic proteins, that is BAX and BAC. So what do? Under normal cells, normal physiology, the anti-apoptotic proteins BCL2 and BCLX prevent the pro-apoptotic protein from creating channels in the mitochondria membrane. So when the need for apoptosis rises, the anti-apoptotic proteins will be blocked, hence giving way for the pro-apoptotic proteins to go and create channels within the membrane of the mitochondria. So the pro-apoptotic proteins are responsible for making channels in the mitochondrial membrane, leading to leakage of cytochrome C into the cytosol. So what happens when cytochrome C leaks into the cytosol? So we can see here our cytochrome C leaking from the channels created by pro-apoptotic proteins. So this cytochrome C that leaks out then goes on to combine with apoptosis activating factor, also called APAF1. So when cytochrome C combines with apoptosis activating factor, the factor will then activate caspases, which are our protease enzymes. So the activated caspase leads to a cascade of caspase proteolysis. The caspases cleave DNA or break it down, activating DNase enzyme, which leads to a coordinated DNA breakdown, hence apoptosis. So let's move to the extrinsic pathway. Just like it states, extrinsic from outside or extracellular. So during the extrinsic pathway, we shall need a signaling molecule coming from outside the cell. Yes, and some of the signaling molecules we can have cytotoxic T lymphocytes or the natural killer cells. So these signals in form of cytotoxic T lymphocytes or natural killer cells originating from outside the target cell have ligands that are referred to as Fas ligands or Fas-L. So these Fas ligands bind to Fas receptors on the surface of targeted cells. So they will come and bind to the Fas receptors on the surface of the cell being targeted for apoptosis. So when they bind, they activate the Fas associated death domain, or FAD. So the FAD, or Fas activated, Fas associated death domain, then goes on to activate caspases. So the activated caspases will then activate each other in a self-amplifying process called the caspase cascade, leading to apoptosis. So here we can see the microscopic view of the process of apoptosis. At our right, we can see condensation and separation of the nucleus of the apoptotic cell. Then on the left, we can see fragmentation of the apoptotic cell, forming the apoptotic bodies. So now, a brief overview of the differences between apoptosis and necrosis. We've seen that apoptosis is programmed. It is programmed cell death. But necrosis is not planned. Like you'll come to learn, it is as a result of external factors, which can be toxins, viruses, things like pressure, nutritional deficiencies. Yes. Apoptosis is not inflammatory, and necrosis can be inflammatory. Apoptosis can sometimes be pathological, while necrosis is always pathological. So, the cases where apoptosis is pathological, we can see this under things like autoimmune disease, under malignancies, under apoptosis, the cell membrane remains intact, like we said. This is where even when the cell breaks up into apoptotic bodies and finally disappears, the membrane will still remain intact. Then under necrosis, the cell membrane is destroyed. Thank you for listening.